All right, hey everyone. So in this video, I'm going to go over the experimental design extra practice. So this is the one with the Fizz Labs, people coming up with that new pain medication for arthritis. So the first task you had was to diagram the experiment. So we're going to take our 20 arthritis sufferers, the volunteers that we got. I'm going to pre-test them. I'm going to basically have them pre-rate their pain level. And I'm making that decision because the question here says, talks about reducing the level of pain. So the best way to gauge how much pain has reduced is to have a pre-test where they rate their pain on some scale and then get the medication or their whatever treatment and then have them rate their pain again on the same scale and then look at the change for each person, look at the change in those ratings. So I'm going to have each one pre-rate their pain. I'm going to randomly assign each of them to one of two treatment groups. 10 are going to get the new medication and 10 are going to get some sort of placebo. And then when that's over, I'm going to have them post-rate their pain. And then I'm going to compare the average change in pain ratings. So I'm going to calculate the change for each person and then take the average of those and compare those between two groups. So there's my diagram. Question 2 asks you to describe your design. So here, what we're testing for is we want to check to see if the new medication is effective in reducing arthritis pain. So that's our goal here. So I'm just going to randomly assign 10 volunteers to receive each treatment. I'm going to have them rate their pain on a 5-point scale. You could use a 10-point scale. It really doesn't matter. So beforehand, I'm going to have them rate their pain on a 5-point scale. I'm going to blind the volunteers and they're not going to know whether they're getting the placebo or the actual treatment. You could make this double blind if there's some sort of third party going in there to ask the participant to rate their pain. You would want to blind that person as well. So it really kind of depends on how you're organizing this. So if you had it being double blind, obviously someone needs to know which patients got the treatment, but you could certainly have the patients numbered and have this outside evaluator keeping track and knowing what treatment each got, but the participant in the experiment doesn't know, nor the person going in and asking them to rate their pain. So if someone's going in and saying rate your pain, that person should be blinded as well, making it double blind. So that's kind of up to you here. And then it specifically said in the question that it was an hour. So I'm going to wait an hour after treatment and then have each person rate their level of pain again. And then I'm going to compare those or subtract those. So my response variable here is the change in level of pain. So I'm just going to indicate here which order I'm subtracting. It doesn't ultimately matter, but I'm going to indicate here that I'm going to do before minus after for everybody. And then again, I'm going to compare the average ratings for each group. If the average decrease in pain level is significantly more for the group that got the medication than it was for the placebo group, I will then say that the medication is effective. In case you're ever asked this, when we talk about what significantly lower means, what statistically significantly lower means, that would mean that the difference in the groups is more than you would expect to happen just by random chance. Again, we don't expect the average changes to be the same at the end of this. We'd be really surprised if they were. So we do expect there to be a difference between the two groups. So the question is the difference large enough that we could attribute it to the medication rather than just the randomness that happens by randomly attributing them to treatment groups, right? The natural variability between the two groups. And then here's my control here. I'm going to say, okay, throughout that hour, I'm going to make sure all the patients kind of wait in the same waiting room so that we can control their activity. We don't want them participating in any kind of exercise or something like that might exacerbate their pain. So we're going to exercise that kind of control. And then we're also going to make sure that they didn't take any other pain medications. I just, again, within 24 hours, I kind of made up that time period myself. But you do want to make mention that you want to make sure that they're not taking other medications that would impact, that would be used to treat pain. All right, and then on the back, we're talking about identifying the subjects. So the subjects are the people or objects being tested. So in this case, the 20 people suffering from arthritis, those were the subjects. Those are the ones the treatments are being imposed upon. And then the factors here, there's only one factor. So there's only one decision we need to make for each individual in this experiment. And that decision is, do they get the actual medication or do they get the placebo? So there's only one factor because there's only one decision I need to make. And there's 2 levels because they're either going to get a full dose of the medication or they're going to get a placebo. So in this case, the number of treatments are going to be the same as the number of factors. And that will often be the case. If you only have one factor, the number of levels and the number of treatments will be the same. And then the response variable, as I mentioned earlier, the response variable, again, you want to think of this as what piece of information are you going to gather for each individual, or what are you going to write down for each individual at the end of this experiment. And for each of these volunteers, we're going to make note of their change in pain level, taking their before score minus their after score. And then for the last part is, we've got our 20 volunteers. Here are their names. We're going to assign them to treatment groups. So we're going to do this using a number table. So here, I'm going to number all the volunteers 1 to 20. You could do 0 to 19. Notice I'm using 2-digit numbers here because when I take the numbers from the table, I have to take them 2 digits at a time. So there will be no number 1. It will be 0, 1. And same thing if you started at 0. So we go 0, 0 to 19 or 0, 1 to 20. It's entirely up to you. So I'm going to take 2 digits at a time from the table. I'm going to ignore repeats. I'm going to ignore 0, and I'm going to ignore any numbers greater than 20. And as you can see, some of that was a little bit of an afterthought here. And we're going to stop once we have 10 unique numbers. And then the volunteers that correspond to those 10 numbers, I'll put them in the medication group. So they'll receive this new medication that we're testing, and the other 10 will get the placebo. And then I went ahead and went through the table here and did this. So again, I'm marking them off in 2-digit chunks. So I'm going to just pre-mark that. And that's a common thing to do if you're taking more than 1 digit at a time from the table. So I'm crossing off a lot of numbers here. There are a lot of 2-digit numbers that are unassigned to an individual. So it's not ideal, but there's really not much else you can do about this. Again, you can come up with some convoluted plan, but you have to then explain that, and you also have to make sure that everybody's equally likely to be chosen to be put in any particular group. So by far the safest thing to do is just go ahead, number everybody, take them 2 digits at a time, keep it simple, and that way you're guaranteed to be sure that everybody's equally likely to have been put into a particular group. And then it just makes it easier to explain as well. So I'm just marking an M here. I wrote up here P, but really I never used P's because everyone else is going to get a placebo. So I could actually erase this part. So I'm just marking an M on here for everybody that's going to get the medication. And then rather than listing the names of people who were chosen, I just circled them here and made a note that those are going to be the ones in the medication group, and the uncircled ones, or the ones without the purple box, are going to go in the placebo group. So that's going to be the thing you're expected to do with this kind of table, right? Have the explanation of how you're going to use the table, and then make sure you're indicating who it was at the end of the day, at the end of this, who ended up in what group. So note that somehow, either make a list of the names of each group, or again, you can mark them on the actual list of names.